What happens to matter at absolute zero for GED Science? Imagine a world where everything is cooled down to the coldest possible temperature. That temperature is called absolute zero, which is 0 Kelvin or minus 273.15 degrees Celsius. At this point, the particles that make up matter are supposed to be as still as they can be. But what actually happens to matter when it reaches this extreme cold? That's what we're about to find out. At absolute zero, the thermal motion of atoms and molecules, which is their movement caused by heat, is almost completely stopped. This means particles are barely moving, and heat energy is nearly gone. But even at this super low temperature, particles don't completely stop moving. Thanks to quantum mechanics, particles still have a tiny bit of energy called zero-point energy. This is the minimum energy they must have because they cannot be perfectly fixed in place and still have zero momentum at the same time. So, atoms still vibrate just a little bit, even at absolute zero. Scientists have never actually reached absolute zero, but they can get very close. When they do, matter shows some strange behaviors. For example, some materials become superconductors, which means they conduct electricity without any resistance. Others turn into superfluids, flowing without any friction or resistance. And in some cases, atoms from a new state of matter called a Bose-Einstein condensate. In this state, many atoms act as if they are one single quantum entity, moving together in perfect harmony. These unusual properties happen because the usual thermal energy that causes particles to move around is almost gone. This allows quantum effects to take over and show their strange behaviors. So, in summary, at absolute zero, the particles in matter are nearly motionless, but they still vibrate slightly because of zero-point energy. Matter can become a superconductor, a superfluid, or from a Bose-Einstein condensate. Although scientists can't reach absolute zero exactly, they can get very close, and studying these conditions helps us understand how matter and energy behave at the lowest temperatures. This is a key part of understanding how physical science explains the behavior of matter and energy under extreme conditions.